One important constructional feature is the shape of the rotor. One is called as the cylindrical, or it is also called as non-salient pole. Another is salient pole rotor. Okay. So what is the difference? The cylindrical pole will simply be in the cylindrical shape, whereas if you consider a salient pole machine, it is going to have its poles protruding out. So that means something like this. These are the protruding poles. So this is how it is going to look like. So you can see that this is in fact little less bulky as compared to the cylindrical or the non-salient pole rotor. Okay. Now two important things with respect to the winding construction is required. One is fractional pitch. So what is meant by fractional pitch winding? What is meant by pitch first of all, right? So if there are two adjacent poles, let us take two poles for example. So that means there are only north and south poles. Then what is the angular displacement distance between the two poles? It is 180 degrees. Similarly, if you take four poles, so that means there is north and south here. Okay. Now what is the distance, angular distance? It is 90 degrees. Okay. Now this angular distance is what we call as pitch. Now each coil that we take a coil like this, right? Now this coil span, if one side of the coil is here and other side of the coil is here, then what do we call this? We call this the full pitch winding. You can write down the definition here. If the coil stretches across the same angle as the pole pitch, then it is a full pitch winding. Okay. But we are using fractional pitch. That means if the coil, one side of the coil is starting here, then it will end somewhere less than 180 degrees. Okay. So that means the new coil now is going to be, one coil is here, another coil is here, which is less than 180 degrees. This is what we call as fractional pitch. Now what is the purpose of this fractional pitch? It is used to suppress the harmonic levels in the electrical quantities. Right? For example, if you take the voltage, this is going to be, ideally it should have only Vm sine omega t. If one phase, if you are taking A phase, it should be Vm sine omega t. But it will also have some additional harmonics. So that means what is meant by harmonics? It is going to have frequency more than the principal frequency. That means if omega is the angular frequency, then you might have Vm sine 3 omega t, that is the third harmonic, and so on like that. So this happens because the machine is not ideal because of a lot of factors, right? Now in order to suppress these harmonics, we make use of the fractional pitch. Now why fractional pitch helps in reducing harmonics? That is not required to know at this level. Okay. Only thing that you need to know is the fractional pitch helps suppress harmonics. Okay. So you can also write the definition of the fractional pitch. If the coil stretches for an angle smaller than pole pitch, it is called fractional pitch winding. Okay, this is called full pitch winding. Another important feature is the distributed winding. So the coils of each phase, they are not concentrated at one point only, but they are distributed over a certain angle. Why do we do this? Simply because we cannot place all of the windings in one slot only. That is, for example, if you are taking the stator like this. Okay. Now the slots, if you are keeping like this, now how many windings can you keep in each of these slots? Right? There will be a limit to it. But then if you keep less number of windings, that means only those number of windings which are sufficient in these slots, then what will happen? You will not get enough voltage, right? How much voltage can a single coil or few coils can produce, right? So that is why to incorporate more number of coils, we distribute them over a certain angle, okay? So that is what is called as distributed winding. So you can write down the windings associated with each phase are distributed over several adjacent pairs of slots. Why I was saying pairs of slots here? If one side of the coil is here, the other side is going to be here, okay? Now the distributed over this angle, if let us say the coils are of a certain phase are distributed over these 3 slots, okay? Then the other side of it will be here, okay? So that means this coil is going to come here and this coil is going to come here, the other side. So that is why we are talking about adjacent pairs of slots, because it is not possible to put all the conductors into a single slot. The voltage due to a single coil is very small, and it is only by placing many coils that we get a considerable magnitude of voltage. That means the required level of voltage that we want, that is only obtained if we keep distributed windings.